Trying not to make too much sound when I lift up the mic. Since most of you, it doesn't look like I recognize the faces of, I'm just going to introduce myself. I'm Wes Tobin. I'm faculty in physics and astronomy here. And it is my honor and pleasure to introduce our speaker today and give you a little information about him first of all. So Phil Plait is an internationally known astronomer, writer, science communicator, and self-described all-around science junkie. He earned his PhD in astronomy from the University of Virginia and spent a decade as a part of the Hubble Space Telescope team at NASA's Goddard Space Flight Center before concentrating on educational outreach, or science evangelism, as he may refer to it. As a science writer, Phil Plait has written more than 7,000 articles as a part of his award-winning blog, Bad Astronomy, which has been hosted on Slate, Discover, Sci-Fi Wire, and most recently through Substack. He has written several books, including most recently Under Alien Skies, and one of my favorites, 2 to the 7th Nerd Disses, A Significant Quantity of Disrespect. Nerd insult book. I like that one. Phil is the writer and host of the PBS streaming series Crash Course Astronomy, which we use in our astronomy A100 and A105 courses. He was a scientific consultant for the 2016 major motion picture Arrival, starring Amy Adams and Jeremy Renner, and the 2017 CBS TV series Salvation. He is a regular as an expert astronomer in docu-series like How the Universe Works, and today we have him here to discuss the upcoming eclipse with us. So without further ado, please join me in giving him a warm welcome, Dr. Phil Plait.
Thank you, sir. Good morning. Still morning, right? Well, I guess you're not awake either. Okay, great. It is a pleasure to be here in Indiana, although I have to say I'm a little bit jealous that you all get an eclipse, and where I live in Virginia, we only get a partial eclipse. It's not going to be as good. So if you get a chance to see it and you're out there, give me a thought, will you? That would be nice. How many of you saw the eclipse in 2017? Only a few this time. Okay. It's a pretty amazing thing, and good for you for having seen it. That's excellent. I've been an astronomer my whole life, and I'm old. And my first one was in 2017. Just never been at the right place at the right time, which is part of what I'm going to talk about here, about why these things are so cool and why they're so rare and special. And this is a tremendous opportunity to actually live in a place where there's going to be a total solar eclipse. Is not something that happens a lot. We were talking about this earlier today, that the last time there was a total solar eclipse, like here in Richmond, right, was in the year 831. So, 1,200 years ago, and the next one won't be for over 1,000 years as well. So to be able to walk outside and look up and go, oh, there's an eclipse right here, very rare. It's a, once every 1,000-year kind of event. So what is an eclipse? Well, astronomers have a fun term, a general term for things like eclipses, and it's syzygy, which every time I say it, my mouth is too dry to say it correctly. Syzygy, it's worth 26 points in Words with Friends if that doesn't also peg me as being super out of date and old. Does anybody play Words with Friends anymore? You're nodding. Yeah, no, they're looking. Do you even know what it's an internet game? Okay, never mind. What is a syzygy? It's just a term. It's a general term that means when you have 3 astronomical bodies in a row, in a line. So an eclipse is a kind of syzygy. But there are a lot of different kinds of them. For example, here's a photo of Saturn. And at the upper right, you can see that little orange fuzzy blob. That's its giant moon Titan. And from the point of view of the spacecraft that took this, the Cassini spacecraft a few years ago, it was here, it was looking at Saturn, and that moon was in a line with the 2 of them. And so if you think of the spacecraft as being an astronomical object, then you have a syzygy. Or if you were standing on Earth and you saw this, that would count. Or Jupiter. Here's a Hubble photo of Jupiter. Hubble Space Telescope took this. And you can see there's a moon on the lower left, another one on the upper right. And those two black spots are actually shadows of moons. Actually, is there a third moon on that picture? One, two, there are three moons. Right. And two shadows of those moons as well. And so that's another example of a syzygy when you have three things in a line like that. So an eclipse is a kind of syzygy, it's a special kind. And what you need for this are three things you need. One is the sun. This is a photo I took of the sun with my own telescope. I'm going to show you a picture of the telescope later too. The Earth, I did not take this. NASA did. They were very kind to let me use it. And the moon, and that's not even a real image of the moon. It's actually a computer generated one taken by stitching together thousands of images taken by a satellite that's been orbiting the moon now for a long time. So you need these three things. Now, this image is not to scale. The sun is about 900,000 miles across. It's huge. The Earth's about 8,000 miles across. So the sun is over 100 times wider than the Earth. And the moon is about a quarter the size of the Earth, about 2,000 miles. So these are grossly not to scale. The sun is about 400 times wider than the moon. So, if this were the sun, the moon would be a teeny little thing. But the sun is 400 times farther away from the Earth than the moon is. So it's 400 times bigger, but 400 times farther away. It's coincidence. And those two things kind of cancel each other out. And so in the sky, the sun and the moon appear to be about the same size. And that is the only, or this planet is the only one in the solar system where that happens. On every other planet, if you were standing on that planet and looking at the moon and comparing it to one of their moons, compared to the size of the sun, the moon would either be a lot bigger or a lot smaller. None of them have a moon that's about the same size as the sun in the sky. So that's a pretty cool coincidence. And it's an important one, and I'll get to that a little bit later. So you all have probably gone out, if you have, sort of average vision, you've gone outside and you've seen the moon. Like just a couple of nights ago, it was full. So it looks like a big old circle in the sky, right? And it's completely lit. And if you wait a week or 2 weeks or something like that, the shape is going to be a lot different. We call those the phases. And so the phase of the moon can be full, or it can be first quarter or second quarter, half full or something like that. And the reason for this is geometry. It's just where it is in the sky compared to the sun. So the moon is orbiting the Earth. In this diagram, the sun is shining from straight down. You see the Earth there in the center and the moon going around it. And on the right is the phase of the moon we see when the moon is in that position. And so I'm going to animate this. Kablam. So when the moon and the sun are lined up right there, we're looking at the back half of the moon, the unilluminated part of the moon. The lit part of the moon is the other side. And so we're looking at the dark side of it, and we don't see anything. And when it's opposite the sun, come on, baby. There it is. Boom. When it's opposite the sun in the sky, we're looking at the fully illuminated half, and so it looks like a big circle. And in between those, like right there, we're sort of seeing the illuminated part from the side, so it's half full. And on the other side, it's the other half is illuminated. I just said half full. I guess that's correct. Anyway, the point being that as the moon is moving around the Earth, we're seeing different parts of it lit up, and that's what causes the phases of the moon. So when the moon is between us and the sun, and we're looking at the dark side of it, that's how you can get a solar eclipse. A solar eclipse is when the moon blocks the sun in the sky. So the question might be, why don't we get a solar eclipse once a month? The moon takes a month to go around the Earth. That's where the word month comes from. It's month, if you want to think of it that way. When the moon gets between us and the sun, why don't we get a solar eclipse every month? We don't. They actually only happen somewhere on Earth once or twice a year, and obviously in one spot on Earth very, very rarely. And the answer is that the moon's orbit is tilted with respect to the direction to the sun. And so sometimes the moon is up high in the sky and it passes above the sun, and sometimes it's lower in the sky and it passes under the sun, and most of the time it just misses. The moon and the sun, while they're about the same size in the sky, are very small. And you might think, I can look at the moon, it looks really huge. It really isn't. Have you ever tried taking a picture of the moon with your phone? And then you look at it and go, God, it's tiny, tiny, tiny. It's really hard to get a good picture of the moon on your phone. Try it sometimes. It's very disappointing. So yeah, please try it and go and be disappointed. That's great advice. It looks big to your eye, but that's because the way your brain and eye work together to see things. The camera, when it takes that picture, it turns out the moon is actually very, very small. And so it's very easy for the moon to miss the sun. Things have to line up just right for them to pass over, or for the moon to pass over the sun and get an eclipse. So here's an animation that will show that. In the center is the Earth, and down there to the lower right is the moon, and they're casting shadows in space. And I found a lot of people struggle with that concept, and I get it. How do you cast a shadow in space? It's space, it's empty. Well, don't think of it as casting a shadow. Think of a shadow as being where you're just not seeing light. Something is blocking your light. And if it's blocking the light, then you're in its shadow. So if I, put my hand up against that light, I can't see the light. I'm in the shadow of my hand. You may not see that. Maybe you can kind of see that on my face a little bit. But if you're out in space and you have a star like the sun, because the sun is a star, and the moon is here, if you're behind the moon, you won't see the sun. You're in the moon's shadow. And that's what that diagram is showing. It's showing the Earth's very long shadow and the moon's very long shadow that stretch out into space. You wouldn't be able to see them like this, but if you were in that shadow, that's the spot in space where that object is blocking the sun. And I'll put this into motion. And usually the moon, is going around the Earth once a month, and that shadow is stretching out into space. But every now and again, things line up just right, even, with the moon's orbit being tilted. Usually it misses, but right here, at just the right time, the moon's shadow passes directly over the Earth. And so if you're on the Earth on that spot, the moon will be blocking the sun in the sky, and you can get an eclipse. To show this at a different angle, I like this one better anyway. This is to scale, by the way. So the Earth and the moon are to scale. The Earth's about 4 times bigger than the moon, and the moon is very far away. It's 250,000 miles away. So it's really, really far away and very, very small. That's why it doesn't look very big in the sky. And its shadow is extremely long. And that's another reason why, like I said, it tends to miss the sun most of the time. And that shadow is so long, it's actually hard to get it to fall right on the Earth's surface. So if I show you here, this is what an eclipse looks like if you're looking down on the Earth and the moon from space. The moon is blocking the sun. Its shadow is falling on the Earth. And if you're in that little tiny spot on the Earth, you will see the moon blocking the sun and you'll get an eclipse. The moon's shadow on the Earth is actually fairly small. I keep saying it's about 100 miles, and I keep meaning to look up just how big it's going to be for this eclipse, and I keep forgetting, so I apologize for that. But the moon's shadow on the Earth is very roughly 100 miles across. And so if you're standing here, it might miss you. And if you're over here, it might hit you. I mean, here and here being a few miles apart. And it turns out, if you're, there are some places, and I'll show you on a map later, there are some towns where if you're on one side of town, you'll see an eclipse. And if you're on the other side, you won't, because the shadow is just missing that other spot. So if you're going to look up in the sky, what are you going to see? This is a computer-generated animation that shows you just in general how this is going to work. As the moon starts to pass in front of the sun, you start to get what's called a partial eclipse. It's taking a bite out of the sun, and it gets bigger and bigger as it moves more and more onto the sun. And then right here is the total eclipse. It's completely blocking the sun, and then it moves off, and then the sun is a crescent and gets thicker and thicker over time. And then the moon finally moves off of the sun. This whole thing is hugely sped up in this animation. It takes about 3 hours from start to finish. For the partial eclipse to start to the end is when the moon moves off. Totality, when the moon is completely blocking the sun, can only be as long as a few minutes long. The longest eclipse on Earth is just a few minutes. In this particular case, here in Indiana, it's going to be about 4 minutes long. The one in 2017, I saw that in Wyoming, and it did pass over some areas around here. That was 2 minutes long. So this one coming up is going to be twice as long. That's fantastic. You're really going to get a chance to breathe it in. You really get a chance to experience it, which is excellent. So what does that look like in real life? Well, this is an animation taken by a photographer in Australia. That's why Eclipse down under, because it's in Australia and they're on the other side of the earth and they're like standing on their heads. No, like two people are smiling. Is it that early in the morning? Okay. That's the level of the humor in my talks, by the way. So just get used to it. So here you go. This is in real time as the moon is just starting to cover the sun. This part of it is called the diamond ring effect, because there's this line, this circle of light around the moon, and this one glary piece from the sun that's just still being exposed. And then right at that moment, the moon is completely blocking the sun. Now we're in a total solar eclipse, and there's that glow around the moon. The moon is very dark, again, because we're seeing the night side of it, the unilluminated half of it. It's dark. If you were standing on the moon there, it would be basically midnight or after sunset. And there's that glow around the moon. That is what we call the sun's corona. Corona is Latin for crown. It is the sun's atmosphere. The sun has an atmosphere. It's not like Earth's atmosphere, the air that we breathe. But the sun is basically a giant ball of, you can think of it as gas. And it has this, but it's very dense gas. Surrounding it is much, much, much thinner gas that stretches for millions of miles. Remember, in this image, the moon, which is close to us, is only 2,000 miles wide, but the sun is really far away and is almost 1,000,000 miles wide. So this corona is stretching out for hundreds of thousands of miles. It's really big. In this image, it actually goes for millions of miles. So even though it's incredibly thin gas, we're looking through so much of it that we can see it glowing. And the thing is, it's extremely faint. The glow is just completely blown away by how bright the sun is in the sky. That's why you can't see it during the day when you look up. But if the moon blocks the very bright part of the sun, that much fainter stuff can be seen. And that's one of the reasons an eclipse is so cool. There's this whole thing to the sun that you cannot see normally, but when the moon blocks it, boom, there it is. And you can look up and see it. And so now the total part of the eclipse is over, and the bright surface of the sun is being exposed again. The corona is kind of going away. You don't see it as well. And over the course of the next, hour or so, the moon would move off the sun. So in general, that's how the mechanics of this works. That's how, the motion of the moon and the sizes and all that stuff works out in the geometry. And what you can expect to see, but what's going to happen here? What's going to happen here in Indiana on April 8th, 2024? Well, let me say, I don't know necessarily, because it's April in Indiana. And remember how it was like warm yesterday? And then you got up and came in today and it was like a different planet. You're nodding. Yeah. Oh yeah. Indiana's like that. A lot of places. I remember I live in Colorado. It was like that a lot. It was really hard to know how to dress for a day. So it's hard to say what April 8th is going to be like in Indiana weather-wise. Looking at the almanac and going back like 100 or 200 years, you can sort of statistically say how often is it cloudy, how often is it clear. And there's about a 70% chance of clouds in Indiana. Does that mean it's going to be cloudy? Well, no, it might be. If you were to bet, maybe you would bet it would be cloudy, but it might only be partly cloudy. And partly cloudy eclipses are still really cool because there are gaps in the clouds and you can see it. Even if it's totally cloudy, the thing about an eclipse is that the sun is going to get blocked by the moon. It's going to get dark. That's the whole thing. It's night during the day, kind of. And so even if it's cloudy, it's going to get dark. And I still think that's going to be something pretty cool to experience. So even if it's not clear, you'll still get to experience something. But if it is clear, you get the big show. So let's talk about that. As the moon is moving around the Earth and that shadow sweeps across our planet, it's actually drawing a straight line across the Earth. But because the Earth is round, it's curved, and I will make that point. Yes, the Earth is a giant ball in space. When you sort of peel that out and make a rectangular map, it distorts everything. You probably remember those maps in school where Greenland is huge, and then when you see it on a globe, it's disappointing. It's like, well, it's not that big at all. When you make maps like this, they distort the sizes of things and distorts the shapes. So yeah, that shadow is moving in a straight line across the Earth, but because the Earth is curved, when you map it this way, it makes the straight line look like a curve. And so what's happening is that shadow is going to touch down on Earth in the Pacific Ocean, down there at the lower left. Then it's going to move up through the Pacific and across Mexico, and then Texas and Oklahoma and a bunch of different states, including this one, and then off Canada. And then as it moves off the Earth, it's going to be over the Atlantic Ocean. So if you're sitting right here, right there, you're going to see basically the sun and the moon rise together at sunrise in eclipse, and the opposite at the other end. And if you're in the middle, it happens during the middle of the day. And that's why being here is so good, because it happens at a reasonable time. Now, on this map, the two blue lines, those two parallel borders of the curve, that is the size of the moon's shadow on Earth. That's one end versus the other end. So that's the path. If you're in that path, you will see a total solar eclipse. The red line in the center is, weirdly enough, called the center line of the eclipse. And if you're in that spot, that's the best place to be, because that's where the widest part of the moon is going to go over the widest part of the sun, and the eclipse will last for the longest amount of time. If you're right on the edge of that map, the blue line, the eclipse will basically last for less than a second. It just starts and stops. Boom, you're done. But if you're in the center line, it'll last for about 4 minutes. So the closer you are to that red line, the better. So let's zoom in a little bit. And now we see Ohio and Indiana. And you get a better sense of where we are here. Indianapolis, for example, is in between those two lines. And so if you live in Indianapolis anywhere, you're going to get to see this eclipse. And I remember I gave this talk in Cincinnati and in Kokomo, and both of those towns are getting split in half by the eclipse. So that's what I was saying before. Half the city is outside those blue lines. It's outside the shadow. They will see a partial eclipse. The sun will be like 99.9% covered, but not 100. And that little tiny bit of the sun that's still shining through is so bright, it washes out the corona. So they won't see that at all. And if you're inside those blue lines, you will. So, and I keep thinking, I don't know how sharp the moon's shadow is. It's fairly sharp. So it could be that you could be like a block away and not see totality, and walk like a block and see it. It could be that sudden. I'm not sure, but I think it could be. So where are we? Well, here in Richmond, we're right there where the blue mark is. This is cool. This is actually a Google map that an astronomer named Fred Espenak, who goes by Mr. Eclipse because he's cool, puts these together. He's really, really smart, and he does all this coding to take a Google map, and so when you click anywhere on it, it tells you how the eclipse is going to go. So there's all that information there. Most of that's not that important, but you know what? I keep forgetting that I can do that. So, event, the partial eclipse begins. So that's just when the edge of the moon touches the edge of the sun for the first time. And unfortunately, I forgot to change time zones. Those times are in Greenwich, England time. So you have to subtract 4 hours. So it's going to happen at 4 hours? 13? No. 6 hours is 13? No, it's 4 hours, because it's going to happen at 3:08 in the afternoon. 15 minus 3 is the partial. I'm looking at the total eclipse. Like total eclipse is at 19, but at 1900 hours, 3 o'clock is 1500 hours. So it's 4 hours difference. Yeah, well, you're 5 hours difference now, but we leap ahead. So it's 4 hours. Yeah, time zones are horrific. They're just awful. And let me say something about Indiana with having a state with 2 different time zones in it, and what a nightmare that is. I'm giving this talk in Evansville, and it's the only place I'm giving this talk that's in Central Time. And I had to like double and triple check that I was getting this right, because I can just imagine if I tell people, yeah, go out at 4 o'clock and the eclipse happens at 3, that would be bad. Everybody misses the eclipse, and then they blame me. So the eclipse starts at 1752, which subtract 4 is 1352. So it's 1:52 in the afternoon. Total eclipse begins at 1908 minus 4 is 1508. 1508 is 3:08. So yes, that's correct. And a matter of fact, oh, look at that. It is. So right where I put that marker, which is kind of in the middle of Richmond, the eclipse, the total part of the eclipse will start at 3 o'clock and 8 minutes and 1 second. And it ends at 3 o'clock and 11 minutes and 51 seconds. So it's just under 4 minutes long. If you were a little bit closer to that red line, so if you were to like travel up to, what is that, Hagerstown or Newcastle, something like that, you'd probably get a little over 4 minutes. Probably not worth the drive to get 10 more seconds, because there's going to be a lot of people who are thinking, I want to be right where the center of the eclipse is. and there are going to be a zillion people there. And then when you leave, the traffic jam is going to be horrific. So I wouldn't suggest doing that. You can see a total eclipse from your dorm or your front yard or whatever. Do it. And so this exact timing changes depending on exactly where you are, but that's pretty close. 3:08 to 3:12, something like that. 4 minutes long. And you can find this map online. I'm going to have a slide at the end with a bunch of different links. And if you want to, you can take a picture and then go to that, type that in, and you can click around and see where all this stuff is. It's actually kind of cool, kind of fun. I wouldn't suggest clicking Virginia because we only get 85% there, and that'll make you sad because it makes me sad. This is pretty cool. This is somebody who took a series of photographs of the eclipse from some years ago, and waited a few minutes between each exposure. And it starts down there on the lower right and moves this way. And you can see the moon starting to come in from the left and moving this way, eating out a bigger and bigger portion of the sun's face and getting a thinner and thinner crescent. And then totality there in the middle. And then as the moon moves off, you see more and more and more of the sun. It's a pretty cool picture. It's a little confusing, I know, but it just shows you how as the eclipse progresses, more and more of the sun is getting blocked by the moon. And let's take a look at what totality looks like up close. I love this shot. It's so pretty. So the moon is in the center. It's black. You're seeing the shadowed side of the moon. The sun's corona, that outer atmosphere, is shown there. This is what it looks like by eye. Okay, if you had binoculars and looked at it, it would look more like this. But even by eye, you can see the corona around the sun. It's milky white. It glows, and it sometimes is smooth or might have a little bit of structure to it. And also around the moon, the edge of the moon, you can see those red blobs. What are those? Well, the sun has a very strong magnetic field. I'm not going to get too sciencey here, but that magnetic field can pull material off the surface of the sun, and it erupts out into space. And you get these huge towering spires of gas. Sometimes they erupt out and then fall back, and you get a gigantic arch of material. It looks like it's on fire. They're called prominences and filaments and towers and spires, and there are all these different names for them. Look them up and online and look at pictures of them because they are super cool. They look like gigantic explosions on the sun. And in a sense they are, because this material is being blown out and falls back down. This material is made of hydrogen. It's hydrogen gas. And hydrogen, for very complicated quantum mechanic physical reasons, likes to glow at a very specific red color. It is IUE red. Now, because now that I'm looking at your uniforms, that's pretty close to the red color that hydrogen glows at. And so that's what you're seeing here. You can see, like, it's a little bit tough, but there are these towers of red gas blurping up out of the sun. There's one that's actually detached and blowing away, an arch going up and down, although it's a little bit hard to see there. Yes. They are so much bigger than Earth. Thank you for asking. Remember, the sun is about 1 million miles across, and the Earth is about 8,000 miles across. So ignoring the moon, if you were thinking this is the sun, there are 110 Earths could fit across the sun. So these, this little blob right there is probably twice as big as Earth, something like that. These are huge, and you can see them with your eye during an eclipse. And the reason you can see them, especially in this one, for example, is because the moon and the sun appear to be the same size in the sky. That coincidence. If the moon were a lot bigger, right, and it covers the sun, it might stretch out to here, and all of those would be blocked. And if the moon were a little bit smaller, it wouldn't be able to block the sun enough, and you'd have a ring of light around the moon, and you wouldn't be able to see any of that. And that happens sometimes. That's called an annular eclipse, because annulus means ring. So there's a ring of, they call it a ring of fire. I like that. It's kind of poetic. This bright ring of light around the dark circle of the moon. That's also a very common kind of eclipse. But because of this coincidence, because the moon and the sun appear to be the same size, you can get all of the structure that you can see right around the sun's surface. Super cool. Here's a photo taken by a friend of mine, Tunk Tazel. He took this in Norway. And I like this one for a lot of reasons, although it's a little bit hard to see what's going on in the ground. the sun is kind of low. Normally you see pictures of the eclipse, the sun's way up in the sky, but he actually shows the landscape, and it's, you know, mountainous, and there's snow, and there's some people camping there. But also, again, the point of an eclipse, kind of the biggest point, is that the moon is blocking the sun. And if you don't have sun in the sky, it gets dark, right? The sun is the source of illumination on our planet. And so it's going to get dark during the eclipse. Now, it's not going to get like pitch black, like at midnight or something like that. It's going to get more like deep, deep, deep twilight. So the sky is going to get darker and darker and turn sort of purple and then blackish. And you can see that here in the sky. The sky is fairly dark up here, but it's bright over here. And that's because the moon's shadow doesn't cover the whole Earth. It's only covering a small part of the Earth. And so while he was standing in the moon's shadow here, somebody who was over there was still seeing a little bit of sun in the sky. And so the sky was still kind of blue. And you're seeing that in this picture. And it can show it to you even better in another picture by Tunk that he took in Australia. And he used a fisheye lens, a wide angle lens, and that distorts the horizon, makes it curved. You know how those wide angle lenses make things look kind of weird. But this is the edge of the shadow of the moon. And over here and over there, you're still seeing sky that is lit by the sun, because that's outside of the shadow. So it's pretty cool. It's a little bit like twilight, but in fact, it's like noon right here. But the moon is blocking the sun mostly if you were here, and totally if you were standing where he was standing when he took that picture. So that's super cool. And one more close-up. This was taken on a partly cloudy day, again by Tunk. I don't remember where this one was. This might have been Queensland. And again, look, you can see that giant loop of hydrogen gas blowing off the sun. And this is just before, I think before, it might be just after, but I think it's before the moon completely covered the sun. So this is still technically a partial eclipse, but it's almost total. And you can see, although some of that is probably Earth's air bubbling and roiling and distorting the edge of the moon, but this kind of shows that the edge of the moon isn't a sharp, perfect curve. The moon, you've seen pictures of it, right? It's got craters on it. It's got mountains and hills and valleys and things like that. So even if it's completely covering the sun, or as it's just about to cover the sun, there can sometimes be a little bit of sun poking through like a valley. If you're looking right at the edge of the moon and there's a valley there, a little bit of sun can poke through, even though it's mostly blocked everywhere else. And if there's a series of these valleys, you can get little spots of bright light along the edge of the moon like that. And these are called Bailey's beads. They've been known for a long time, and it was some guy a couple of 100 years ago who figured out what was going on. It's like, oh yeah, it's the edge of the moon. The edge of the moon is all jagged, and so we're seeing pieces of the sun through that. I don't know if we're going to see that this time. And honestly, I don't remember if it happened in 2017, because my mind was just being destroyed by what I was seeing for the first time in my life. And I can't remember a lot of the details, but it was pretty cool. And I'll talk a little bit more about that in just a sec. There are other things to see in the sky besides the eclipse, because again, the sky is going to get dark. The sun is going to go out for 4 minutes. And what happens when the sun goes down, right? It's nighttime. And if you go outside, you can see stars, you can see planets. If you were to go out, not tonight, but on a clear night over the next few weeks, and go out right after the sun sets, just as the sky is starting to get dark, there's a very, very bright star to the southwest. That's actually not a star. That's the planet Jupiter. It's one of the brightest objects in the sky. It's pretty cool. And that'll be visible during the eclipse, way up to the upper left of the sun and moon. It'll be pretty obvious in the sky. Venus is up right now in the morning, and it's incredibly bright. It's way brighter than Jupiter. It is the third brightest natural object in the sky after the sun and the moon. And it is just a perfect, brilliant, gorgeous point of light. It is so bright, you cannot believe it. Has anybody here seen Venus? Oh, you're missing out. You probably have, and you haven't even thought about it. A lot of people mistake it for an airplane. That's how bright it is, like an airplane heading right for you. That's how bright it is. And honest to God, I get emails all the time when Venus is at its brightest from people who are saying it's a UFO. They're like, it's following me, right? They're driving along, and it's like it's following them through the trees. And it's like, no, it's not a UFO. It's Venus. It's just really far away, so it looks like it's following you. And they're like, no. I know it was a UFO. And I'm like, well, you just told me that you were looking in the direction of Venus which is the brightest thing in the sky, and you didn't mention seeing Venus and a UFO. So I'm telling you, it's Venus. And pilots have mistaken it for UFOs. Every time I hear somebody, a brilliant object that was following me, it's like, it's Venus. And it's like a joke. If you ever watch shows like the X-Files, anybody watch X-Files anymore? They always joke. It's like, no, you just saw Venus. And it's like, well, actually you did. Saturn is a fainter planet. It's going to be tougher to see, but it might be visible if it's dark enough. And there's also a comet in the sky right now called 12P Pons-Brooks. Pons and Brooks are two astronomers who discovered it, and 12P is just a designation that we give comets. It's not visible to the naked eye, but it almost is. You can see it with binoculars right now. And over the next month, it might get brighter. Comets are hard to predict. Famous comet observer said, comets are like cats. They both have tails and they do what they want. This one might get bright enough that you can see it with the eye. I didn't put it on this map. When I was a kid. Oh, okay. You can take a piece of paper and a pin, and guess what you do? You poke the paper with the pin, you make a pinhole. And that forces, if you point that paper then towards the sun, that forces all the light to go through the pinhole. The rays of light from the sun are parallel. And that's kind of the definition of what focusing something does, is you're making light rays parallel. So it makes if you take another piece of paper and hold it down like that, it'll make a little image of the sun on that piece of paper. This works. It's kind of cool. And the very first cameras ever made did that. They didn't use lenses, they used pinholes. And you can make an artificial pinhole for yourself. You can like curl your fingers up and look through it. But you don't look through it. But I mean, you can take that and project an image of the sun onto your hand or onto a piece of paper, something like that. And it's really neat. What else can you use? Well, leaves have little tiny holes in them. And there can be lots of leaves that overlap, and there are gaps between the leaves. They make little holes. This is a picture of a side of a house. This is a wall. This is a window in the side of the house. This took me forever when I first saw this picture to figure out what I was looking at. It's like, what am I seeing here? This is a window. This is the glass. You're facing the wall, the window, or the wall in the window. The sun is behind you, and it's reflecting in the glass. So you're seeing the reflection of the sun in the glass, and you can see a tree there. And all the holes in the leaves in that tree are acting like pinhole cameras and projecting an image of the sun onto the wall. So all of these little arcs that you're seeing is the crescent sun, is the moon blocking like 99% of the sun, leaving that little thin crescent. We saw this in the 2017 eclipse, and it was really cool. You can just look on the ground and see hundreds of images of the sun being eclipsed. And we actually grabbed a colander out of the kitchen, one of those things you drain spaghetti with, an old metal colander with circular holes in it, and projected like a couple of dozen images of the sun on the ground. It was pretty nifty, and it's worth doing. That's a safe way of looking at the eclipse. So here's the thing, right? We're talking about the sun. Do not look at the sun without protection on your eyes, okay? It is literally the brightest thing you can see, and it can damage your eyes. We have nurses here. I can talk biology. Years and years ago, I did some research on this, and I read some ophthalmological journals, and that's another great word, ophthalmology. People who study the mechanics and the biology of the eye. And it turns out that there have been many cases of people who have stared at the sun for different reasons, none of which is good, I'll tell you that. And they've damaged their eyes. But nobody has gone permanently, totally blind. You're not going to go completely blind forever by looking at the sun. However, you can have complete blindness that's temporary, so you might not be able to see for hours or days or weeks, bad, or you might have small spots in your retina burned. It will burn little holes, little black spots in your retina, and you will have those forever. You have floaters in your eyes. You see sometimes those little weird floaty things. Those are actually cells from the back of your eye or floating around, and you see them out of focus, and they're irritating, and you have to kind of shake your head, and they go away. It's kind of like having those, but all the time, little black dots in your vision. So do not do that. You are harming your eye by looking at the sun without protection. Having said that, when the moon completely blocks the sun's surface, perfectly safe. You don't see the bright part of the sun. You're just going to see the corona. You can just look at it and you're going to be fine. But before and after that, those 4 minutes, you have to be wearing protection for your eyes or else you're going to hurt yourself, and don't do that. So, I mean, don't hurt yourself. Yes, have adequate safety. That includes, oh, I forgot to pull one out. Eclipse glasses. You can find these all over the place. I won't speak for you, but are you going to? So there you go. You can get a free pair of these glasses. They're also like $2 if you want to buy a pair. You can get them online, and they're just made of paperboard, cardboard, and they have filtered plastic on them that it blocks a lot of the sunlight, enough that you won't hurt your eyes by looking at the sun. I have a couple of pair I keep around. I look at the sun all the time. One of the reasons is that sunspots, those dark blotches you can see in photographs of the sun sometimes, there's one on the sun right now that is so flippin' huge, you can see it just by looking at the sun. Normally, you need a telescope to see them because they're small, but this one is huge, and I've been watching it. And the sun rotates just like the planets do. It takes about a month to spin around, and the sunspot is just now going on the far side of the sun, so you can't be visible. But in a couple of more weeks, I'm hoping it'll still be there and come back around, and y'all can see it with your glasses. It's actually pretty cool to look at the sun and see this thing. So that's a safe way to do it. Binoculars, if they're filtered correctly, if you take a regular pair of binoculars and look at the sun, you're going to boil your eyeballs. Do not do this. Boiling eyeballs, bad. But I have a pair like this that are filtered. They're very dark. You cannot use them for anything but looking at the sun. You're not going to be looking at birds or anything with these there because they're really, really dark. But they block enough of the sun that you can actually see the sun. And that's really cool because it magnifies it enough that you can start to see some details. You can get a solar telescope. This is mine. That picture of the sun I showed you at the beginning of the talk. This is what I use to take it. This has a series of filters inside of it that block most of the sunlight, makes it safe to see. If you take regular binoculars, you can point them at the sun. Again, do not look through them at the sun, but you can point them at the sun and then project an image of the sun onto a piece of paper. That's what I did here. This is the shadow of my binoculars. That's the sun projected on a piece of paper, and there's a bunch of sunspots. I took that picture as well. And if you want to be perfectly safe, stay indoors and just watch it on your computer. I don't suggest that if it's clear. You should really get out and see this for yourself. Yes. Oh, excellent. So I'm assuming that some will have filters that you can watch the partial eclipse, and some will have. Yeah. Okay. So there's a kind of filter. I also have one at home for my telescope that for a different telescope that goes on the front end of the telescope and blocks all that light from coming through. And so during the partial phases, you can actually look through a telescope at the sun. And then once it's total, you can take that filter off and look through the telescope at the sun as well and see the corona in detail. So I want to talk about, actually, just to be perfectly clear, there's a bunch of things you can hear about. Can you look at the sun through an eyepiece filter that goes at the back end of the telescope? And the answer is no. If you've ever taken a magnifying glass and burned a piece of paper with it, right? You're taking all that sunlight and concentrating it down on a dot, and it gets so hot it can burn paper or leaves or something like that. This is true. You don't want to do that. If you have a filter at the back end of your telescope where the eyepiece is, where you put your eye, you're taking all that light from the sun and concentrating into a little dot and putting it on a piece of glass that has been darkened on purpose. Dark stuff absorbs heat better than lighter stuff. And so that filter can get incredibly hot. And when you heat glass, it can shatter. And so you're actually putting your eye up next to a thing that is made of glass that can shatter. That's bad, right? You don't want something shattering into your eye. So these are very dangerous. If you have any DVDs, some people say you can hold those up. Those let through infrared light, and infrared light can damage your eye. So those aren't good, even though they block a lot of the light we can see. They still let through kind of dangerous light. Not that you guys probably have exposed film lying around if anybody's a photographer, but they used to say you can use that as well, and that's not good. And some Mylar is okay and some isn't, so don't take a chance with anything like that. Use the safety rated Eclipse glasses you can get or something else like that, to make sure that you're going to see this safely. Now, I have talked about the science of this, the physics of it, the geometry, the coincidence of the moon and the sun being the same size, the timing, and what you're going to see. I've looked at a lot of stuff through my telescope, and I go out under the stars all the time, and I love it. It's beautiful. But it's not necessarily special, right? I can go out any night in the winter and see Orion or the moon in the sky. And I love it every time. It's beautiful. It's like having a hamburger. It's always great to eat a hamburger. But every now and again, you get that, oh, that perfectly cooked, oh, with the caramelized onions and the cheese melting on it. And it's a special burger, right? Those are the ones that stand out. There are astronomical events that do this as well. They're rare and they're beautiful, and you don't get a chance to see them very much. They are special. And a total solar eclipse is at the absolute top of that list. They are so beautiful, so strange, so eerie that a lot of people get really emotional during an eclipse. And I remember reading that years ago thinking, really? And then I kept reading. It's like it happens a lot. People scream, they laugh, they're jumping up and down with joy. A lot of people weep with emotion. They are so moved emotionally that they are crying because of this. And I didn't understand that until I saw my first eclipse 7 years ago. And now I totally get it. It is overwhelmingly beautiful. And this eclipse is going to be better than most because the corona should be much larger than usual and have a lot of structure in it because, and I should have mentioned this earlier, the sun's magnetic field gets stronger and weaker over a cycle of 11 years. You may have heard about the solar cycle, the sunspot cycle, something like that. That's the sun's magnetic cycle. When the magnetic field is weak, you don't get many sunspots. And then over 5.5 years or so, it gets stronger and stronger. You get lots of sunspots. And the corona, the sun's atmosphere, is highly affected by these magnetic fields. So instead of that sort of smooth, white pearly thing I was showing before, you get lots of structures in it, filaments and streamers and loops. And we're expecting that for this eclipse. So that's going to be magnificent. It's going to be huge in the sky, like, like as maybe like as big as your hand, but certainly extending way out from the sun. It's going to be spectacular. So the beauty of this is going to be intense. Staggering is the word I use. I was just standing there in awe of what I was seeing. I have a scientific set of reasons I think this might happen. I won't go into too many details. I think it's because this event takes a long time to build up to totality. As the sun is getting more and more blocked by the moon, as it's getting more and more eclipsed, the sky color starts to change, the shadows on the ground start to change, animals are sensing that something is going on, crickets start chirping and things like that, the temperature starts to drop, and it starts to get dark. And this all takes a little while, and it builds that sense of excitement. Like a really good movie takes time to build up to the big, chase scene or whatever, the big fight scene at the end in an action movie. So it builds this emotional investment into it, and you get that payoff of this magnificent view in the sky that you can just see with your own eyes. And it only lasts for a few minutes, sometimes even seconds. But 4 minutes, that's a good amount of time for this. And so I can't suggest strongly enough to get out and see this. If you're able, please go do this. Do it safely. Be a part of this event so you can see it with a crowd. It's even better with a crowd of people because everybody's excitement builds on everybody else's, and it makes it more of a fun thing. It's like going to a football game versus seeing it. It's more fun to be there in the crowd. So I would strongly urge you to do this. It is just magnificent. It is poetry, it is music, it is artwork in the sky that nature is giving you for free. But if you want to do a little bit more, even if you don't have any scientific training, there is science you can do during the eclipse. Scientists are curious. Well, that's what makes them scientists. But scientists are curious about things like, how do animals behave during the eclipse? Does the weather change? What other effects can we see? And a scientist, one scientist, or even a team of scientists, can't do huge amounts of observations across the path of an eclipse. But there are going to be millions of people who are going to be watching this. And they can take note of their observations and send it to the scientists. The scientists can collect it and analyze it and figure out what's going on. So you can do things like observe how wildlife is affected. Do birds chirp or stop chirping during the eclipse? Do crickets start rubbing their legs together? You can look at the sun's corona and look at the structure of it. How bright is it? How far away from the sun can you see it? You can take pictures of it. Do weather observations. Does the weather change? There are many more sophisticated things you can do, like testing Einstein's relativity. That's actually very hard to do, and you need really sophisticated equipment, but some people have that. And some, like high schools, are launching high altitude balloons with packages of detectors and things to check like things like air temperature change and radiation changes and things like that during an eclipse. And these are all things that anybody can participate in. And there's a group called SciStarter that has collected these things. And if you want to sign up to do some of these things, there are scientists who are saying, we need your help. And they can send you stuff. There's like an app you can download to listen to bird calls and do things like that, or check the weather. And then when it's done, it will send the results to the scientists, and they can research it, analyze it, and publish the results. And all of these projects are listed at scistarter.org/eclipse. However, you're going to be tempted, especially at your age, you're going to want to take pictures of this, right? Maybe if you don't want to do the science, you're going to want to take pictures, you're going to want to take video, you're going to want to do all that kind of thing. If you want to do that, fine. Don't take a lot of time. Take a picture or two during totality if you want to. That's great. But I strongly urge you to just be there. Just experience this. Don't miss out on the beauty of this because you're fiddling with your camera and you can't get your app open, or it won't focus or whatever, or somebody's, getting in your way or whatever. Don't sweat any of that stuff. Just be present for this, because it really is just that beautiful and just that an amazing of an experience to see. So I would strongly recommend you do that. Finally, my friend Katie Mack is an astrophysicist. She's really smart. And years ago online, she put up this tweet on Twitter. I really like it, just with emojis. So if the Earth is between the sun and the moon, you get a lunar eclipse. And if the moon is between the sun and the Earth, you get a solar eclipse. But if the sun is between the Earth and the moon, you get an apocalypse. And that's because if the sun were in between the Earth and the moon, we would be inside the sun. And that's not a very good idea. It would actually vaporize the planet. So I've always liked this joke. You'll see it copied a lot. People have made t-shirts out of it and everything, and they never credit her. So I always want to make sure she gets the credit. Look at how many likes that had and retweets. And that was in 2014. I wonder how many it has now. I'm not going to go to Twitter to check it, though. So let me leave you with this. These are the links I was talking about. MrEclipse.com. Eclipse Wise is another good one that has a lot of information about this. NASA, of course, has an Eclipse website. The GreatAmericanEclipse.com is another good site. TimeAndDate.com has a ton of information. And I'll be writing about this on my newsletter, which I put out 3 times a week, which is at badastronomy.beehive.com. And I have lots of other stuff there. Dumb jokes, music I like. It's a newsletter, recipes, whatever. But it's mostly astronomy, and I talk about astronomy news there too. So it's looking like I'm probably going to be in Virginia for this eclipse, which means I don't get to see it total. But I really, really hope that for here in Indiana, it is going to be clear skies, and you all have the time and the ability to get out and see it, because it will rock your world and change your life. So good luck. Thank you. That's a good question. So if we have such a hard time predicting the weather that far in advance, how can we predict eclipses that far in advance? And turns out we can predict eclipses centuries in advance. Maybe not accurate to a second, but we certainly know what day and what area of the world they're going to be on. And the answer is that weather is a very different phenomenon than the moon going around the Earth. The moon is orbiting the Earth under the effect of gravity and really nothing else. And we understand this super well. The equations that we write down to describe the orbit of the moon are understood extremely well. I mean, Newton invented these equations 400 years ago, and we've gotten only better at it since then. And so with something like the moon, you can predict where it's going to be pretty precisely a long way into the future because its motions isn't really affected by that much stuff. And the stuff that does affect it, they're very, very small effects, and they add up over time. So we don't know where the moon is going to be literally a million years from right now, but 500 years from right now, yeah, we can do pretty well because we know its motion that accurately. Weather, totally different. Weather is incredibly complex. It's affected by the constituents of the Earth's atmosphere, the temperature, Earth's rotation, land masses, sea masses, lakes. The moon actually affects weather. The moon's gravity pulls on Earth's atmosphere and changes things. The weather affects itself. If you're measuring temperature and a cloud goes in front of the sun, it gets cooler. Well, if the air gets cooler, things can happen. Water can condense out of the sky. And then, so, oh no, water's condensing out. That changes the water vapor content in the atmosphere. That's going to change the weather. So this is a self-perpetuating cycle that makes it incredibly difficult to predict the weather, even sometimes hours into the future. And it's astronomers tease meteorologists a lot. We tend to know each other because they tend to like astronomy, and we were always wondering about what the weather's going to be like when we want to see the sky. It's like you guys can't even get the weather right half the time, and we can predict eclipses in 500 years. But it turns out, yeah, what they're trying to do is super hard. The math that governs how weather works is incredibly complicated. And that's why it's so difficult to do. And I'll be honest with you, to me, it's amazing that now we can predict the weather pretty accurately several days in the future, when that used to be very hard. And, you know, we had this tornado warning last night. Or was it a watch? I always get those backwards. Everybody does. Okay. The fact that they can now have radar and show where tornadoes are forming and predict where they're going to be pretty accurately. When I was a kid, that could not be done. That was way too advanced. And now we're starting to do it routinely. So we get better at this stuff. But that's why these are two different systems. One's very simple and one's very complex. So there you go. Sure. Anyone else? You're all very quiet. Really? I can keep waiting. Anywhere you can look up and see it. It's as long as you're in the path of totality, and all of Richmond will be, anywhere in town is as good as anywhere else. I mean, you want to have I guess I would say you want to be in a place where you can see a lot of the sky, and we're in Indiana, so that's probably not that hard. I lived in Colorado, and so sometimes, you know, the mountains might block something, or where I live in Virginia, I'm surrounded by trees. I would actually have to drive someplace to get out where there are no trees. If you can see a lot of the sky, that's good, because then you might be able to see Jupiter and Venus. You can see the corona really well. Maybe near the beginning and the end of totality, you'll see a part of the sky that's not black. It'll be sort of bluish over there. So that would be kind of cool if you can see down to the horizon. But honestly, at the bottom line is you just want to be able to look up and see the sun. For me personally, the idea of literally walking out my front door and looking up and seeing it has a lot of appeal, because I had to drive to Wyoming to see it last time. So that's pretty cool. Or oh, okay. You still got 5 minutes. All right. Oh, thank you very much. Oh yeah, don't forget the cookies. Those are good. Right there. You better hurry. Yeah, sure. Oh, no worries. Yeah, this clock says 10:24, so I thought we had an hour. But of course not. I know. This clock right here.
Yeah.
It's on
Lovely.
saving time. It's like when the clock is I have my clock. Oh, this thing is so heavy.